Hello everyone. I would like to talk a little bit about the first exam and what you can do to prepare to do well at it. Just a reminder that the three exams, exam 1, exam 2, and the final exam will be occurring in person when we meet at the regularly scheduled lab time. And I know this is different than the quizzes, so just be aware that you should want to plan to come to take the exam when you would normally be coming to lab. We'll talk about the course objectives, some logistics for the exam, the focus of each of the modules, and what you can be doing to prepare to do well at this. The course objectives are in the syllabus. Not all of the course objectives will be covered on the first exam, but here we're showing the ones that will be. I'm not going to read through these. You can read them yourself, and there are enough of them that they go over the course of 2 slides. So please just kind of read through that to make sure you're aware of that information. And we'll go through each module and talk about where we saw these things coming up and what to do with that. In terms of the logistics of the exam, how this will work is you'll show up at the regular lab time, and the first 75 minutes of class will be set aside for completing the exam, and then the remainder of the class time will be doing the atomic spectra lab. We'll be doing a shortened version of that lab. We won't do everything that's there. We'll do part of that based on having a shorter period of time within which to do our lab activities. I want to just remind you to be aware that if other people are still taking the exam, you should not start on the lab because that could interrupt them and distract them from the work that they're doing. So if you get done early on the exam, feel free to take a break, go elsewhere on campus if you would like to, and come back 75 minutes after the start of class, and we'll get into the lab activity. Some additional logistics are related to items that will be important for you to have while you are taking the exam. You will be provided with a periodic table as well as a list of polyatomic ions. Those are things that I will be giving you as part of the exam packet. So you don't have to memorize those. Those are things you would want to know how to use. You should bring a pencil and a calculator. Calculator should not be your cell phone. It should be a separate device. And it's actually very important that you have a calculator. The 75-minute time frame of the exam does not allow the time to do long division on the side of your paper. So you will need to have a calculator in order to get done in time. I do know they sometimes have some for rent at the library if you don't have one, so that could be an option for you. You may, if you would like to, bring a note card. So it's a 3-inch by 5-inch card. You can put whatever you think would be useful to you on that card, and you can use that card while you're taking the exam. You can write on both sides. It's fine to do that, and you can use as small a font as you are able to read legibly with your normal degree of magnification. So however you want to do that is fine. The utility of the note card is often that the process of deciding what to put on it is very helpful to your studying. So one card of notes is fine for the exam. Do not bring a cell phone. Now, of course, if you need to be in contact with people for an emergency, that's fine. But it shouldn't be something that, I can see it should be put away while you are taking the exam. Let's go ahead and talk about the material in terms of how heavily each of these modules will be weighted on the first exam. So you can see the percentages there. Module 6, again, was the one that we spent 2 weeks on. So that one has a higher weight than the others for that purpose, for that reason. Also, Module 3 is a bit sparser than some of the others, so that one has a little bit of a lower weight. But overall, they're all fairly equal. So you do need to master the material from each of these modules in order to succeed on the exam. Let's go ahead and talk about each of these modules and what you will need to have mastered to do well on them. So for Module 2, we had scientific notation. We had significant figures. 4 significant figures that both involves counting them in a measurement and as well as performing a calculation based on the measurement results. The other big idea here was the conversion process. And this is a big idea throughout the course. So important things are recognizing units, using the SI scale for conversion. So you do need to know those SI prefixes and how they work with conversions. You need to be able to work with units raised to a power, and any kind of dimensional analysis question could be involved here. In Module 3, we had additional applications of conversion factors, specifically with density calculations. We also looked at the scientific method, classifying matter properties, transformations, and energy, as well as temperature conversions. In Module 4, we looked at subatomic particles, so that would be the protons, electrons, and neutrons, and how we use things like mass number, atomic number, and atomic mass to talk about the relationship between these particles. We also looked at the periodic table, finding information from the periodic table about specific elements that could be related to the subatomic particles. And it could be other information that's maybe not related to those particles. We learned the differences between metals and nonmetals, and there were some special groups that had names that you want to know where those groups are on the periodic table, and then identify elements within those groups. If you have a compound, you should be able to classify it as a molecule, an ionic compound, or an acid, and then be able to name compounds correctly. So this could be either that you are using the name to write the formula, or you're using the formula to write the name. So you will need to be able to do that basically in both directions. Module 5 was about the mole concept. So there were several conversion factors that we looked at here, between atoms and moles, between moles and grams, and those could be in either direction, and you could do those in series. So you could have atoms, moles, and then grams, or vice versa. We looked at conversions between percent composition and empirical formula. Again, those could go in either direction. And we looked at finding the molecular formula. So a lot of calculations in Module 5. And you would want to be able to do any of them. In Module 6, again, this was the longest one. We looked at balancing equations and classifying equations and predicting the result of double replacement reactions. And then we got into stoichiometry. So here we're looking at additional applications of the mole concept. So you can, we began here to look at the conversion from moles of one thing to moles of another. We also looked at converting from mass of one thing to mass of another, and there's not a direct conversion there. You have to go through a series of steps. And there are lots of other possibilities, and the idea here is not to memorize each option, but to be familiar with the dimensional analysis necessary to get you from whichever option you're started with to whatever option that you are looking for. So this is going to require a lot of practice. Once you have mastered stoichiometry, we then moved on to additional applications such as limiting reagent, percent yield, and enthalpy. So many calculations in Module 6. It does build on the material from Module 5. Okay, so you need to master Module 5 before you can master Module 6. And the mole concept is very, very important for this exam. So please make sure, even if it feels a little bit overwhelming, that you are taking the time to learn that, because if you don't learn the mole concept, it will be a challenge to succeed on this exam. Finally, I want to talk about a few things I would recommend to you in order to do well on this exam. So you have had several worksheets that go in the various modules that we've covered. Make sure you've mastered all of the material that you've seen on any worksheet so far. What you see on the exam will probably be similar to things you have previously seen on a worksheet. Make a note card for yourself that includes information that you think is important to remember, that you don't think you will remember, you think you might not remember during the course of the exam. At this point, I would recommend taking the practice exam. So there is a practice exam on Canvas, and set aside 75 minutes to do that. So treat the practice as if it were the exam itself, and that's the best way to kind of get a sense of if you have more work you need to do in studying, or if you are already ready enough for the exam. If you are using a reference, for example, while you're taking the practice exam, so if you're scrolling through your book to find an example that you wouldn't have when you take the real exam, then you're not really treating it the same way. So what you would do in that case is you would be taking it and you'd realize, oh, I don't know how to do this problem. Proceed through the rest of the exam and then realize this is an area you need to focus on, go back, figure it out, and then do what you need to. One additional thing I should mention about the practice exam. So these are exams that I had previously used in other semesters for this course. One of the things that has changed during the pandemic is that we kind of had fewer multiple choice questions, so moved away from using those. They don't work as well in an online learning environment. And also, there are often multiple choice questions that there's an additional skill to doing well at them that isn't really part of the chemistry material. So there's a skill to multiple choice questions, and I don't think that is necessary to succeed in chemistry. So the exam you see will not have those same kinds of multiple choice questions you might see on some of the practice exams, but it could have questions over similar material. So some of those might be a bit more challenging. So just if you do have questions on any of those multiple choice questions, feel free to ask. One of the most underrated pieces of advice, I think, in terms of getting ready for an exam, is to make sure that you are you are well rested. So we do have an early class. I would recommend that even if you normally don't get a good night's sleep, that you make it a priority to get a good night's sleep the night before the exam, and also that you're able to eat breakfast before the exam. So make an exception for this. Make sure your brain has all the benefits it needs to do well. The exam is kind of special. It's a higher priority than the other things in the course in terms of your grade. So treat it as if it is special. So good night's sleep, eat breakfast, give your brain the best chance to do well. If you have questions at any time through this process, please feel free to ask. The discussion board is there. Um, for this exam, for this discussion board, anything you put on will get full credit. So if you just say, yes, I agree, I want more practice with this kind of exam, this kind of question that somebody else had mentioned, that would be fine. You can see the tutors, you can see my office hours, whatever resource is helpful. This week is the best week to make sure you are getting the help you need to do well. So good luck, everyone. I hope you all do great, and I look forward to seeing you at the exam.